such lectures regarding to the antibodies are most welcome. Please start. Thanks, sir.
Hi, this is Atul from California. Can you hear me?
Yes, sir. Yes.
Can you hear me? Yes. Okay. Thank you very much for the introduction. And in the last couple of years, we all have gone through the coronavirus pandemic. And now today, everybody, no matter what the background is, everybody has heard the name antibody. Even a fruit seller, a vegetable seller in India knows about antibody, at least he has heard about it, and a lot of us do not know what is an antibody. So before we start the lecture, let us just see in very simple words what is an antibody. Okay? Antibodies are something that are naturally produced by your body whenever a foreign substance, an unwanted substance, which could be a bacteria, a fungi, virus, allergen, whatever it is, it enters the body. Then the body starts making antibodies to fight off that foreign material. This is very simply what the antibodies are. So today we are going to talk about when the antibodies were discovered in the past, what is the present status of these antibodies, and where are the antibodies going from here. And I will try to make this lecture as simple as possible so everybody has a message to take home. So let us see. Are you able to hear me? Is everything clear? Yeah. Yes. Okay. So let us see how the antibodies or when the antibodies were discovered. And before even I go to that, anybody will say, who are you? And what is your qualification to talk about antibodies? So let me just run through my background so you get an idea who am I and why am I talking about antibodies. So I got my master's in biochemistry back in 1975, almost 47 years ago, from the University of Lucknow. So I am a student of the place from where Dr. Mona Saxena is, and she is the one organizing this conference. And then I got lucky and joined All India Institute of Medical Sciences, and I did my PhD from that place in biochemistry. And during my PhD program, I was involved with anti-pregnancy vaccine. We were developing a vaccine to control birth control vaccine, and that was the time I started working on the antibodies. So back in 1975 was the time when I was making antibodies to all kinds of hormones, SCG, LH, FSH, TSH, all kinds of polyclonal antibodies were being developed at that time. Okay? Now, then in 1983, I got my PhD, I left from there, and I did my fellowship in Japan, and there I was learning and developing about the
Welcome to Zoom. Enter your meeting ID followed by 2.
So I was involved in developing monoclonal antibodies. In 1984, I moved from Japan to San Antonio, Texas, in USA, and there I was a faculty member for 7 years, and I was heavily involved in prognostic markers in breast cancer, which again are all antibodies in breast cancer. So you can see from 1975 I started working on antibodies, then going to Japan, then coming to United States, and in 1991 I moved from academia into antibody industry. And in the last 30 years I have been in the antibody study. And during this time I have founded, I have sold multiple biotech companies. So that gives you an idea that in the last more than 45 years, I have been doing nothing but studying and developing and using antibodies. So that gives you that, I believe, that qualifies me to talk about antibodies. Let us see how the antibodies were discovered. So back in 1890, 130 years ago, there was a German physiologist and a Japanese physicist. These two people did some experiment and made some very important observations. What they did is that they injected some guinea pigs with diphtheria bacteria, and then they collected serum from these guinea pigs and injected to other guinea pigs which were suffering from diphtheria. And surprisingly, what they found, that the animals were cured just by giving blood of a guinea pig which was immunized with diphtheria bacteria to the infected animals, and they were cured. And based upon these observations, they reported that there must be some neutralizing substance in the blood that can fight infections. So they did not do anything about antibodies, and this is exactly, I tell you, this is exactly what we are talking today when we say that we can collect the blood of a person who got infected with coronavirus, and we can use, and if he got cured, we can use his blood, his serum, to cure other patients who are suffering from coronavirus. So what we observed 130 years ago, we are still following it today. Instead of animals, we are talking about humans. Okay, so this is how the antibodies were discovered, and let us go through the term. So that time, in 1890, these guys, they did not know anything about antibodies. They said, hey, it is some neutralizing substance in the blood. So back in 1891, there was a German scientist, and he came up with a word, anti-corpor. And corpor means body. If you guys, you have a corpse, like a dead body corpse. In India, we talk a lot about the corporal punishment. So corp means the body. So anti-body. So back in 1891, I imagine 130 years ago, somebody coined the word anti-corpor. And now let us see the timeline of antibody evolution, and I will match it. My friends, I will match it with my timeline. And we will see that in 1891, the term anti-corpor, the word anti-corpor was coined. Then in 1953, they gave the DNA double helix model. That was back in 1953. And interestingly, because this is a year Queen Elizabeth has died, I tell you one thing, that the Queen was coronated on June 2nd, 1953, and that is the day I was born. So 1953, June 2nd, 1953, Queen getting coronated, DNA model was described, that was the time. And in 1975, Milestone and Kohler, they came up with the hybridoma technology, which revolutionized the field of antibody, and that was the time when I got my master's in biochemistry from the clinics. Then in 1984, 9 years later, Milestone and Kohler, they got a Nobel Prize for hybridoma technology, and that was the time that after finishing my PhD, I moved to USA. In 1986, the very first monoclonal antibody, CD3 antibody, OKT3, was approved by FDA for therapy. And that was the time, it was the same time when I published very seminal papers, the role of HER2 in breast cancer. Then in 2003, the genome was sequenced, and that was the time I moved out of academia into industry, and I started the company that I had started in 93, I sold that company. 9 years, so I started a company in 93, but in the year 2003, when the genome is sequenced, that was the time I sold that company and attained financial independence. So then I could do whatever I wanted to do back in 2003. In 2013, the biosimilars were introduced. Biosimilars means that the patent has run out, any company can make the generic drugs, and that was the time I started another biotech company, which I am running today, is called the Neo Biotechnologies. Then in 2016, there was a very big group, very big meeting about the antibody validation, IWGAV, International Work Group for Antibody Validation, and that was the time we started doing protein arrays. And in 2020, when there was a pandemic, I got a very important German collaboration, and we have a company called MSVA. So that is the timeline of the antibody evolution, which matches with somehow with what I have been doing in the last 45 years. Let us see how does an antibody look like. An antibody is a Y-shaped structure. I'm trying to make everything very simple. It has got 2 light chains and 2 heavy chains, and it looks like a Y. It is just a Y structure. And I am so much fascinated by this Y structure that the company which I am running now, Neo Biotechnologies, the logo of that company is a man standing just like an antibody. This man, if you see, the posture of this antibody, this man is just like an antibody. And interestingly, my friends, this picture is my picture. This is my profile, standing me, and this is my signature pose. Today, wherever I go in the world, I go to many different countries, wherever I go in different places, I take a picture of myself standing in this pose, and I call it as my signature pose, as an antibody. Now, during this period when I told you that the guys back in 1890 up to 1975, all the antibodies generated were polyclonal antibodies. And from 75 onwards, people are making monoclonal antibodies. And very simply, what is the difference in a poly versus mono? Instead of going into the complexity, and I can talk all day long about the differences, what I need to tell you is, you guys simply need to understand that a polyclonal antibody is made by a living organism, by a living person. The monoclonal antibodies are created in the lab. That is a fundamental difference. There are lots of other technical differences. Let us not worry about. But we understand that mono versus the poly versus mono. And now we learn is that the antibodies that are raised against the same antigen, they are raised against the same foreign substance. You will think these are monoclonal antibodies. Those against the same foreign substance, they should be similar. What we have learned over the years, that the antibody produced are very different. And I will take you a case study of a HER2 antibody. HER2 is a very important antibody protein because this is the antibody which is very important for breast cancer diagnosis as well as treatment. So here you will see antibody 1 and antibody 2. Both of them are made against the same HER2 protein. If you are doing a simple immunohistochemistry, but you look at them, so you say, great, both antibodies are very good. But as I said, that the antibodies made against the same antigens are not same. We analyze the same antibodies by a technology which is called protein array. I mentioned about protein array that in 2016, there was a big group for the antibody validation. Here you can see the antibody number 1 on the top, it is reacting only with one protein, and that protein is HER2. And HER2 is also called ERBB2. So this antibody is reacting only with one protein, and that protein is ERBB2, while the antibody 2, which is looking here, if you see here, it is reacting with other proteins. So this antibody is not good. But a lot of people, my friends, a lot of people looking at this data will not know what is a good antibody and what is a bad antibody. Another example is, I will give you an example of another antibody which is called PLAT, placental alkaline phosphatase. This protein is found exclusively in human placenta. So here you can see pancreas, kidney, all male tissues, muscle tissues, connective tissue, they do not contain the mRNA or the protein. mRNA and protein is there only in placenta. This is what we know about this protein. The antibody which is being sold today in the market, which is a benchmark antibody. I tell you, in all the diagnostics everywhere, they are using an antibody which is called 8A9. And I can show you here that when we tested this antibody in our lab on different tissues, yes, it reacts with placenta as expected. In addition to that, it is reacting with muscles. You can see all the brown color here. It is reacting with prostate. It is reacting with the heart muscles. It is reacting with the stomach muscles. And this is what the people are using. And this is not a good antibody. I showed you just before that the PLAT is only in human placenta. So when our lab new biotechnology made the antibody, we used tissue microarrays. We tested, when we were developing antibodies, we tested antibodies on a variety of tissues. All the human, 50 different human tissues were tested to find the right antibody, and this is what we have created. The PLA antibody made by our company in collaboration with a German collaboration, which I told you that this is the collaboration I did back in 2020, pandemic time, we made an antibody which reacts exclusively with placenta and nothing else. And this is what the antibody should be. That the antibody should behave just like what is expected from the mRNA expression. Then, my 40 years of experience in the market, I can tell you, my friends, that more than 70% of the antibodies today on the market are not good. They are not specific, they are non-specific, and they react with a lot of other proteins. And this is really scary. And the point is that the companies selling the antibody, customers using the antibodies, they don't know. The company does not know they are selling a bad antibody. The people, all the diagnostics, the pathologists, all the researchers using the antibody, they do not know. Billions and trillions of dollars. And a lot of publications are not reliable at all. So this is the take-home message I want to tell you is that antibodies are important, but a lot of antibodies on the market are not the right antibodies. Okay? So today, antibodies are used for research, and in the research area you can do different techniques. You can be running ELISA, you can be doing immunohistochemistry, immunofluorescence, Western blotting. Antibodies are important and they are used in research. Antibodies are used in diagnostics. All diagnostic assays, I tell you, whenever you go to the clinic for the diagnosis of any disease, and the doctor or the technician takes either your blood or your stool or your sputum or your tissue after the surgery, they all are tested by the antibodies. Okay? And if the antibodies used are not good, you are not going to get the correct diagnosis. And then now lately, the antibodies are also being used in therapy. That is the latest, that a lot of antibodies are now going for the therapeutic applications for personalized medicine. And what I can tell you is that a lot of diseases, not just cancer, rheumatoid arthritis, heart disease, multiple sclerosis, all different diseases today are being treated by antibodies. That is the future of the antibodies. So I told you what was the past, how the antibodies were discovered. I told you the present, that antibodies are being used in research and diagnostics, and a lot of them are not good. High quality antibodies are needed in the market, and at the same time antibodies are going into the therapeutic area. And let us see, in the last 20 years or so, FDA has approved more than 100 antibodies for therapeutic applications. And I am just giving you the names. All these antibodies are being used, are approved by FDA for the treatment of different diseases. One antibody which is very critical today for the treatment of breast cancer is called Herceptin, sold by Genentech in billions of dollars. And I am very proud to say that I was instrumental. I am one of the first people showing the implicating the HER2 in breast cancer, and based upon my research, Genentech developed this drug. And now it is out of patent. India is developing a biosimilar to Herceptin. So what is the take-home message from today's lecture? The take-home message is simple. The antibodies are extremely important as research, diagnostic and therapeutic tools. Number two, that these are today the most preferable antibodies are validated antibodies. The antibody should be validated, and we have realized that a new class of antibodies, which I did not talk about, called the recombinant antibodies and the rabbit antibodies, these are the most preferable antibodies. So we know antibodies are important, we know that we need fully validated antibodies, but it is a big challenge. Even today, with all the technological advancements, my friends, it is extremely difficult to make monospecific, fully validated rabbit antibodies. And the future is that antibody-based immunotherapies are emerging as the personalized medicine. It is just a matter of time you will see And you can see the biotech industry and all the stocks of the biotech companies are going through the sky because of this reason. Every company is now talking about antibodies and drugs. I tell you that I am very proud to tell you, my company, Neo Biotechnologies, we have developed more than 8,000 monoclonal antibodies. We are one of the largest bank of antibodies in the world, and I have all the people supporting me. So you can see me here standing with multiple people behind me, helping me in developing these antibodies. And when somebody today made a comment that Atul, this is just like the Indian movie that you have 12 arms and 2 eyes. दो आंखें 12 हाथ. दो आंखें 12 हाथ. So today the new bio team, so we have, I tell you, all over the world we have a lot of collaborations, lot of companies making products for us. We have somewhere between 100 to 200 people helping us in this endeavor of making validated monospecific antibodies. And proud to every antibody we have made is not the greatest antibody. We have 8,000, but large majority of them are great antibodies. And last slide I will say thank you for the madman. People call me the madman in California. Thank you very much. If anybody has any questions, anything to ask me, I am here to answer. But I tell you that we have a lot of people who are watching from my lab this presentation, and I am very thankful to all the people who have supported us over the years making this collection, and I believe and I hope that this will help people in research and diagnostics and someday in therapy.
Hey, Doctor, can we ask a question?
Sure.
Doctor, I would like to ask, like you have been producing that certain clones which are being invented by your new biotechnology, and there are some clones which are IVD approved clone. So how do you differentiate between your antibodies clone and other clones, and how the technology differentiate for a specific clone with the different antibody?
Right.
Take an example of HER2 itself. Like if you feel that there are good clones which are in which pathologists have a lot of confidence, like EP3 or SP3 or any other clone, same way. I'm like, how do you differentiate these clones from one manufacturer to second manufacturer?
Right. So I simple thing is I tell you, if we are not talking about the FDA approval, IVD approval, if we are talking about pure science, and we are talking about the quality of antibody, I showed you a good example of PLAP.
Correct.
The antibody which is IVD approved for X, and it is every day being used in the lab, is the 8A9. We are imagining it is a very lousy antibody.
Right.
But it's IVD antibody.
Correct.
So what happens is that big companies, they go out, they get things approved by FDA, whatever be the quality, people just end up using the same antibody. There are, I can tell you, there are a lot better antibodies than the IVD approved antibodies. And the big companies, what they do is that they have their products IVD approved, and the small company is not able to compete with them. So I can tell you that there are better antibodies to HER2 than the antibodies which are FDA approved.
No, I agree, Doctor. I agree, but my question is still, I think I'm still not satisfied, because I want to know, like, how the companies develop one clone to second clone, and how do they make their clones superior to each other in their marketing skills?
So I tell you, our criteria is very simple. Our criteria is that the antibody we develop its reaction should match with the mRNA expression of that protein as shown in the Human Protein Atlas website. There is a website called Human Protein Atlas, HPA, and there we have the mRNA data for all the proteins in the human body. The ideal antibody should behave just like where the mRNA is. You tell me, my friend, I am asking you a question. You have an antibody which is showing a staining in a tissue that does not contain mRNA. So how is that possible? You just make a story and you say mRNA is there, it is unstable, maybe it gets lost. No. This is an argument I have every time with the chairman of pathology department, the largest pathology institute in Germany, MSVA. I work with them and they tell me, Atul, the antibody has to match the mRNA expression data. So you have mRNA in the tissue, but the antibody is not here. That is not a good antibody. Okay, this is something a lot of customers, a lot of end users really cannot do. You just go by what the company is telling you. Hey, this is a good antibody, it will be approved. But companies are developing, especially we and other companies are trying to develop better antibodies which match with the expected data. And if they don't match, they are not good. So
then how these different clones are made?
So when you make how the babies are made, it is just like that. Whenever a new antibody is made, whenever a new antibody is developed, you give it a name.
Okay.
So I give names depending upon what is the symbol of the antibody, what is the official symbol of the antibody, and then we say, for example, HER2 is called ERBB2, and if in my inventory this antibody is located at 7,229 location, I call the clone number ERBB2 729. So these are arbitrarily assigned numbers or name, just like you name your babies, okay, just like how you name your pets. But the important thing is that when you buy or when you use an antibody, you have to ask one very simple question. So what is the validation? I don't care about the FDA approval of this thing and I will be approved. What is the validation? Hello?
Yeah, Dr. I can hear you.
So so don't get trapped. I know, and luckily you guys in India are not obligated, at least not obligated as in America, that you have to use in diagnostics only the Ayurvedic antibodies. In India you have the option to use what you like to use. And the simple thing is, I am again telling you a simple thing, that you look for the validation date. And I have once again I will tell you another story that I am working with a very large group in Germany. They do 500,000 slides every year. And they are refusing to use a lot of IVD antibodies, some of the IVD antibodies, and using other antibodies which they have tested. I recently visited them and I was holding, when I showed you my picture of me holding the TMAs, the tissue microarrays,
yes,
there were 30,000, with 30,000 human tumors. So this group in Germany is testing antibodies and this variety of tumors, and then they decide what is a good antibody and what is a bad antibody. So they are obligated because they have a stainer, they have to buy the antibody from different companies, they are in a contract. But wherever they find a better antibody, they develop a lab-developed test, LDT, and then they use an antibody outside of the IVD approval. If somebody is using, once again, if somebody is using a PLA antibody 8A9 and you call it that it is IVD or 2, you will make a wrong. Germany telling me that they have made wrong diagnosis. They have made wrong diagnosis. Now they will go back and they are looking at the diagnosis they have made. They feel very sorry. You say, hey, Atul, now your antibody is a lot better. So it is a matter of time, and you guys have to be smart and you have to question what you are using. Price does not matter. I can tell you one thing. There are lots of antibodies you give me for free, and I will say, please keep them out of my diet. I do not want them. The price is the last thing. A cheap antibody which gives you a wrong diagnosis and confuses your experiments is very expensive. Is very expensive. So don't be fooled by the prices. And my friend, I can tell you 70% of the research papers using antibodies are nothing but non-trustworthy. Today, and this is not my statement, you can go and check it out, the NCI and NIH, they openly say that because of the bad quality of antibodies, the papers that are published, the research that is published is of no meaning at all. And today a lot of journals are refusing to publish papers if antibodies used in the study are not fully validated. Grants are not being awarded if the investigators are not using validated antibodies. So the take-home message, very simple message for everybody. Antibodies are extremely important, and this is where the future is. Antibodies will be used in all kinds of different diagnostics and therapeutics. Very, very important, but you've got to be careful. After 100 years of experience developing antibodies, after my personal experience of 45 years, I can tell you it is the biggest challenge to develop a good antibody.
Thank you very much, Doctor. Can I ask one more question?
Yes, sir.
Doctor, new techniques for diagnostic like NGS is there in the market and it's growing with the rapid pace even in India also. How do you? I know that it is not possible for every patient to afford the NGS diagnostics comparatively to the immunohistochemistry or any other method of the diagnostics. What do you see that is there going to be a threat to the antibody business or development in antibody business?
Antibody business is not going anywhere. I can tell you that. Even after people are talking about antibodies, we are talking about aptamers, and we are talking about in situ hybridization, DNA, and there are mutations, and in order to know the mutations, you have to do the sequencing of the samples. Okay. Companies are developing mutation-specific antibodies. Companies are developing. One thing for sure, antibodies are not going to go away. They are not going to be replaced, at least sometime in the near future. I do not see anything that people talk aptamers, the people who are in the antibodies will be out. But the beauty of the antibodies, what I have realized is that they are so specific. The nature has given us something. The body produces antibodies. They are true magic bullets. If you inject a HER2 antibody in a female who has gone through breast cancer, you inject in the arm, within a matter of minutes, all the antibody will be in the breast. They are the magic bullets. So it's a specificity. हाँ जी, मैंने भी कुछ पानी में से निकाल दिया मैंने कुछ पानी में से निकाला था oil but the long and short is, once again, take home message, antibodies are critical for diagnostics, therapeutics, and all the fundamental research. But the important thing is, you've got to be careful, use the right antibody. That is the only message. And finding a right antibody is just like finding a needle in a haystack. The market is flooded. There are hundreds of thousands of antibodies on the market, and a lot of them are not good. Companies selling do not know that they are not good. People using them, do not know they are not good. So you've got to be careful. Research money is very scarce. You have to be careful what you use. You have to be very careful when you are using it for diagnosis. Recently, we have an antibody which is called CPA1, which is a pancreatic cancer specific antibody, and my collaboration in Germany, they told me, hey Atul, we have made some wrong diagnosis in the past because we didn't have this antibody. So, important thing is that you got to be careful. Don't be fooled by the prices.
Atul sir,
Don't be fooled by the prices. Once again, you give me a free antibody, I will not take it if it is not good. And if it is a good antibody, I will climb the mountain. I will cross the oceans to take it.
Atul sir, very thanks.
Thank you, sir. Have a great day.
Thank you.
Such an eminent type of lecture which was based on the antibodies, and no doubt nowadays its role as well as therapeutic and diagnostic role is too much, and our students and researchers has been got these points. So next session is, we are waiting for next session also. Sir, madam, I have next session. Our next session is Dr. Uma.